All right, welcome back. We are on I'm now on page 9 in your notes, dealing with section 7.3. We're going to take a look at a few warm-up exercises here just to make sure we're all on the same page before we do this. So, I'm going to start with multiplying, adding, subtracting, combining like terms, all that. I have to distribute this 4 in here, so I end up with a 4x squared plus 4. Just distributing a 4. Here, plus sign in the middle. I'm simply going to add like terms. X squareds, x's, 2's, 1's. I'm putting everything together. So you get an x squared plus x minus 1. Because these two are the only two that are in common and will go together. And subtraction. The only weird part about subtraction is I have to make sure that I distribute that in there. So I end up with an x minus 2 minus x squared minus 1. Which gives me negative x squared plus x minus 3. So the only weird part is make sure if you have a negative out front here, you have to distribute that to everything. Multiplication. This is double distribute. Double distribute, you end up with an x squared minus 2x plus x minus 2. That's taking this x into everything, and then taking this negative 2 into everything. Combining like terms here, you should get an x squared minus x minus 2. And the last one, special cases. This is not, I repeat, this is not simply just x squared minus 4. No, that is not what we do here. When you have an x minus 2 squared, this is the same thing as x minus 2 times x minus 2. And I will double distribute just like I did in this number 4 back over here to get an x squared minus 4x plus 4 when I'm all said and done. We're going to use all of these concepts because now we're getting into composite functions and working with power functions. We will come back to this vocab here with power functions. Not really all that important yet, but just, I don't know, knowing that this is a power function where A is a real number and B is usually some sort of rational number. This really isn't all that important. What is important is being able to do example 1 down here is can you add, subtract, multiply, and divide two functions, meaning we're going to be given this, and they want you to be able to add, subtract, multiply, and divide those. So let's start with adding. 3x minus 5 plus 5x plus 8. Oops. Plus 5x plus 8. Making sure I put stuff in parentheses. Adding together like terms. I'll get an 8x plus 3. Now, we are going to come back to this whole concept of stating the domain. We're going to get to that in a second, so leave some space over here. So, because right over here we are going to state the domain of this. We'll get there. Next one, we need to subtract. So, I go 3x minus 5. And making sure I put it in parentheses of 5x plus 8. The reason I have to put it in parentheses is because I must take that negative and I must make sure that it gets distributed to everything. So technically this is 3x minus 5 minus 5x minus 8. Combining like terms, you end up with a negative 2x minus 13. Again, we'll get to the domain of that one as well. We'll get there in a second. Multiplying these from the previous slide, you know that if you got two things jammed together multiplied like this, you double distribute. Double distributing the 3 in there, getting the 5 in there, you should end up with a 15 x squared minus x minus 40. We'll get to the domain of that in a second. And the last one is division. A lot of the times when you put these two functions over each other, there isn't going to be a whole lot that you can do. The only way you'd be able to cancel something is if they all had it in common, and since they don't have anything in common, your circle, you're good. All right, let's have this discussion on domain. Domain, if you remember back from chapter 1, is, I'm going to write it over here, domain are your x values. Or a lot of times we also call this the input. So when it says, back here in the directions, when it says to state the domain, it is just asking you what numbers could you plug in for x in any of these given equations. What numbers would work for x and you wouldn't do anything illegal? Well, rather than talking about what we can put in, so domain is really asking you what can you put in there. Easier question instead is to say what can't I do? And we have had there are kind of two laws of math that we have had that you can't do. For example, one of them is you can't divide by 0. You can never, ever, 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 ever have a 0 down here. It's just a rule of math. You can never have a 0 down here. And number two thing you can't do is you can't have the square root of a negative number. Meaning if you ever get a square root and this is a negative, that's where we got into the I stuff. So you can't do that either. As long as one of these two things isn't happening, the domain, the question is, what can you put in? The answer is everything. The only thing you wouldn't be able to do is if it's being divided by 0 or square rooted by a negative number. Let me show you what I mean. Right here, I don't see any square roots. I don't see any fractions. I don't see any division. So therefore, the domain here is all reals. All real numbers, meaning anything will work in there. Domain here, same concept. I don't see any radicals. I don't see any fractions. So the domain here is all reals. Number 3, yeah, there is an x squared, but it's still not a radical. You're still not square rooting anything. It's still just being adding and subtracting. So the domain here is also all reals. And by the way, if you really want to get technical, the symbol for reals is this. So if you just wanted to write that instead of all reals, you could have. All right, but we need to talk about this last one because this last one does have one of our exceptions in it. It does have a denominator. It's got an x down there on the bottom. So the domain for that, this bottom, I'm going to rewrite it on another page, this 5x plus 8 cannot be equal to 0. So you need to ask yourself the question, what value plugged in here would give me 0 because x can't be that. It can't be 0. So what I'm going to do is I'm going to solve this for x, given that it does equal 0. 5x equals negative 8. By subtracting 8, dividing by 5, I will get negative 8 over 5. That means that if you were to plug in negative 8 over 5 into here, you would get 0, meaning you would have a 0 right down there. And since we can't have that, we would simply state that it's all reals, except x cannot be negative 8 over 5, because if it is, you get 0 on the bottom. That is the concept of domain. It's really not too bad. You just have to keep in mind these two rules. You can't have, these two rules down here. You can't have 0 on the bottom, and you can't have radicals that are negative numbers. All right, let's do example 2. I'm going to go through the same for process. I'm going to add, subtract, multiply, and divide. So I'm going to go a 2x to the 1/2 plus negative 6x to the 1/2. This goes back to the last video on combining like terms. If I have 2 of them plus negative 6 of them, I got negative 4 of them. This is also where we have to watch our domain a little bit, because the domain here cannot be a negative number because of this x to the 1/2. Since we know that's square root, this cannot be a negative number. So rather than write x can be everything but a negative number, we can just simply say, okay, x can be greater than or equal to 0. Subtracting these just means I got to switch the sign in between here. Combining like terms, I will get 8x to the 1/2. Same concept, your domain here, your x would have to be bigger than or equal to 0 because of this x to the 1/2. Your domain would have to be bigger, greater, or equal to 0. Can't have negative numbers. Multiplying these, 2x to the 1/2 times negative 6x to the 1/2. I'm going to multiply those numbers to get negative 12. Add the exponents because these are the same base, add the exponents, x. Here, the domain is all reals. Except you can't have a radical of a negative number. So we are going to give us the x greater than or equal to 0 again. You don't have to put this all reals, but technically it's anything bigger than 0. And the division one, 2x to the 1/2 over negative 6x to the 1/2. Same concept. I'm going to cancel these like a fraction, subtract my exponents, so I end up with negative 1/3. Now here the domain is fun, because not only can you have no negative numbers, so x would have to be bigger than 0, but the reason you can't put the line under here, meaning x can't be equal to 0, is because of this right here. You can't have 0 on the bottom. So since you can't have 0 on the bottom, and it can't be equal to 0, you do not include the line. All right, What I want you to do is try this example 3. I'm going to put the answer to this online. I'm going to put the answer to this example 3 because there isn't technically a try it for these. And I want to see what you come up with. Yes, you're just doing multiplying, dividing, and subtracting, but make sure you watch which one you're subtracting from which down here in this letter C. So I will put this answer online.